What is up, pre-algebra students? This is lesson 27. Our objective is, what are some laws of exponents and how can I use them? Now, a lot of times people hear laws of something and they start being like, man, more rules I have to follow. I don't really want to do this, blah, blah, blah. So if you want to, instead of calling it a law of exponents, you can call them shortcuts of exponents, because that's really what they are. They're just trying to help us see patterns as we do this stuff and see if we can shorten up that work. But just remember, if you have like x to the fifth, it means x times x times x times x times x. So you're going to list all of those out. And that's why there's a 5 up here, is because there's 5 of these down here. So let's just do a little bit of investigation. So this right here, x cubed, means x times x times x. And this here, x to the fourth, means x times x times x times x. Now if we count up, there's 1, 2, 3, 4, 5, 6, 7x altogether. So this would be the same thing as x to the 7th. Let's do something similar here. There's 5 of these here, so 1, 2, 3, 4, 5. 3 of these here. 1, 2, 3. And then as we count 1, 2, 3, 4, 5, 6, 7, 8. So this would be the same thing as y to the 8th. And let's do this here. Z, there's just z. And this one means times z times z. So it's going to come out to be z to the third, because there's 1, 2, 3 of those. So z to the third. Now, if you look back over these, you might have started to realize a pattern. How could we use 3 and 4 to get 7? Well, if you add them, 3 plus 4 gives you 7. Same thing here, our exponent was 8. 5 plus 3 is 8. This one is something plus 2 is equal to 3. So actually that has an unwritten, unseen exponent on there of 1. Maybe I should just highlight that to make sure that we see that. If there's nothing written there, then it's highlighted as it's an implied 1. Alright, so let's just see if we can talk about this law of exponents. If the bases are the same, like this where they both have a base of x, and they have exponents up there, do you see a pattern? Notice 3 plus 4 gives me 7, 5 plus 3 gives me 8, 1 plus 2 gives me 3. So if I want to finish out this law, I could say x to the a times x to the b is equal to x to the a plus b. So that is the first of our 3 law of exponents. Go and copy that into your quick reference. Alright, now let's do some with division now. Let's look at the numerator here. This means x times x times x times x times x. This part means x times x times x. So if we start reducing, there's 1, there's 1, there's 1. What I have left is x times x, or x squared. X squared is my answer for that one. Let's look at another one here. My numerator is going to be 1, 2, 3, 4, 5, 6, 7. At the bottom I have y times y. So the book calls this canceling out or reducing, but I like to say reducing. It's not actually what I wanted to do. So this y and that y become 1. This y and that y become 1, and what's left over is 1, 2, 3, 4, 5 y's. Y to the 5th. one more similar idea here. It's equal to z times z times z over z. So we'll just see here, oh look, those reduce. And then I have z times z, which would just simply give me z squared would be the answer there for that one. So now let's see if we can continue on. 5 and 3 to get 2, 7 and 2 to get 5, 3 and 1, right, because there's an implied 1 here. That'd help you get z squared. Well, yeah, we just take the exponent of the top one minus the exponent of the bottom one. So it's going to be x to the a minus b. So it's your second law of exponents. We got one more. And I might suggest that you put these down in your quick reference to keep this in a safe place. Alright, so let's investigate even more. So I have this expression in here in the box that's being raised to the third power. So that would mean I take that box times the box times the box. Since that box is 5x, this is going to be x to the fifth, x to the fifth times x to the fifth times x to the fifth. So if I express those all out, or I could use that first property we talked about, this would be x to the 15th. X to the 15th. This one is going to be y cubed times y cubed times y cubed. Is that it? Yeah. Oh, one more. Times y cubed, because there's 4 of them. 1, 2, 3, 4. So again, applying that same base from the first one, I need to say 3 plus 3, which is 6, plus 3, which is 9, plus 3, this is 12, so this would equal to y to the 3 plus 3 plus 3 plus 3, which is equal to y to the 12th. And that would be your answer. And then z squared, that just simply means z times z, and that's equal to z squared. Okay? Your homework is on page 178. Do all the practice set, all of them from lesson 27 and from 26, and then 7 more of your choice. I know you're going to do an awesome job. Good luck.